Section number 41 is entitled Slopes. Slope is how steep a line is. For example, how steep a hill is. We'll call this the horizontal, and we like to know or have some measurement on how steep that line or hill is. Well, we might call that slope 1. M, for some reason, stands for slope. The slope for this line, which is not as steep, its slope might be a half. This slope, say, would be 2. This slope might be 250. As the angle gets bigger and bigger, the slope really grows. In fact, maybe here the slope is 2, and this other slope was 25. And this slope is going to be, say, 5,000. Now, if the slope, say here's where you start. That's where you start. If the slope kind of goes to the right, that is, if you go to the right and the slope is above you, the line's above you, those slopes are positive. Positive 5,000, positive 250. Remember, if there's no sign, it's understood to be positive. If as you go to the right, just go to a point on the line. If you go to the right, if the line is above you, then the slope is positive. After all, if you have this line, you take this point on the line, you go to the right, the line is not above you. The line is below you, right there. If you pick that point, if you go to the right, the line is below you. Those are negative slopes. Those are negative slopes. And we'll draw some right now. This, let's use a different color. Use blue. That has a negative slope. The slope will be very small, say negative a half. How do I know it's negative? I pick a point on the line. If I go to the right, the line is below me. The line is right there. That's what made it negative. If I take a point on the line, if I go to the right, the line is below me. That makes it negative. If the line was above me, that would make it positive. That's a negative slope, negative a half. This line is steeper. Its slope will be more negative, negative 1. This slope might be negative 25. This slope might be negative 250, just like the other side, except these are now negative, negative 5,000. Okay, as the angle gets bigger and bigger and bigger, the slope either gets more positive or more negative. And for the record, along the origin, horizontal, is the slope to 0. The slope of this line right here, slope is 0. So the slope measures the direction in a way, positive and negative, and how steep the line is. How steep the line is. Of course, each and every one of these lines continued on forever. Each and every line that I drew, it goes in both directions forever. Same with the blue line, the ones that have negative slopes. So that's what slopes are. It measures the steepness of a line. And it tells you if it's a positive slope or a negative slope. Now, if you have just one line, you have this line. If you had to walk that portion of the line or hill, or this portion, what would you say about the steepness? And I hope you would say they're just as steep. Walking up here is just as hard as walking up there. They're both just as steep. With the horizontal, they make the same angle. They're the same angle. Okay. So, on any line, the slopes are the same for any points. That is, if I ask you what's the slope of that portion of the line, if I told you it was 1 1/3, and I ask you what's the slope of this portion of the line, you should tell me it's also 1 1/3. And if I ask you for this much smaller portion of the line, you should tell me it's 1 1/3. And if I ask you what's the slope of this big portion of that line, from here to here, you should tell me it's also 1 1/3. A big part of the line, a little part of the line, most of the line, hardly any part of the line, slope is going to be the same. If you find out, oops, I made a mistake, the slope of that line is 1 2/3. 1 2/3. Well, then you better go back and say, oops, these must also be wrong. Slope is 1 2/3. They're all the same. Okay, no one part of that line is steeper. No part of that line is any steeper than any other part of the line. One line, one slope. One slope. Well, that's not true. One line, one slope. Now, 2 points, as we talked about before. 2 points. This point and this point, it determines a line, namely this line. And associated with every line is a number. And that number is called the slope of the line. Maybe the slope is 3. So if I give you 2 points which determine a line, you should be able to compute the slope. Because every line has one and only one slope. And if 2 points nail down what line you're talking about, 2 points determine a line. So those 2 points must also determine our slope. The slope of a line, is m equals delta y over delta x. Delta means changing. It means changing. So the top is the change in y. So that means change in, and that means y, over the change in x. So if I give you 2 points, 3, 5, and 4, 9, compute the slope. What's the slope? Remember, x and y. X and y. Well, what's the change in y? If you go from 5 to 9, you went up 4. Okay? and the change in x. If you go from 3 to 4, you went up 1. Positive over positive is positive, which you don't have to write down. And 4 over 1 is 4. The slope is positive 4. If you were to graph these 2 points, the slope would be 4. 1, 2, 3, 1, 2, 3, 4, 5. That's 3, 5, and 4, 6, 7, 8, 9. Right there. That's 4, 9, that second point. So let's move them over. This is the second point, 4, 9. What's the slope of this line? 4. Which is the same as 4 over 1. That is, the change in y is 4, the change in x is 1. If you go from one point to the other, if you go up 4, 1, 2, 3, 4, and you go to the right one, because the change in x is 1, you add another point, which was exactly what happened. If I told you 2 points were 2, 7, and 3, 5, well, let's make it 8, 5. Find the slope. Well, from 7 to 5, you went down 2. And from 2 to 8, you went up 6. Positive over negative is negative, and 2/3 reduce 2/6 reduces to 1/3. That's the slope that contains those 2 points. Here is 2, 7, and here is 8, 5. The slope of that line is negative 1/3. And it makes sense that it's negative, because if I pick any point on the line, if I go to the right, the graph is below me. And if I go down 2, I have to go 6 to the right. I pick this point. I go down 2 to 5, and then I go 6 to the right. I'm at 2, 3, 4, 5, 6, 7, 8. I end up right here. Suppose you want to find the slope between these 2 points. You go from negative 2 to 5. Since this change in y, I'll draw a vertical. You go from negative 2 to 5. A lot of you would say 3. No. From 2 to 5 is 3, but we're not starting at 2. Say hello to 0. It won't hurt you. So negative 2 to 0 is 2. And then from 0 to 5 is 5. So 2 plus 5 is 7. And to be real careful, you went from negative to positive. That's a positive change. You went up. And now you're going from negative 7 to 2. Since it's a change in x, I'll draw it horizontally. You're going from negative 7 to 2. Say hello to 0. You went 7 and 2 is 9. You went up 9. And positive over positive is positive, and 7 over 9 cannot be reduced. If you're going, at one point is 3, 7, and another point is 5, 7. What's the slope? Well, it's the change in y over the change in x. If you go from 7 to 7, your change was 0. If you go from 3 to 5, your change was positive 2. And 0 divided by 2 is 0. 2 times 0 and only 0 is 0. You have 0 pieces of candy, you have 0 pieces of candy, and you share them between 2 people, each person will get the same amount. They will both get 0. What if you have negative 8, 2, and negative 8, negative 2? Well, the change in y, you went from 2 to negative 2. You went from 2 to negative 2. Say hello to 0. Hello to 0. You went 2, and then you went 2 more. You went 4. You went down 4. And the change in x, there is none. And negative 4 divided by 0 is undefined. 0 times nothing will give you negative 4. That is the only reason why it is undefined. Let us do one more, and then we'll talk about why the answer actually makes complete sense. What is the slope between 3, negative 2 and 3, negative 2? Well, the y's are the same, so there was no change. Oh, the x's are the same. There is no change. And this is called indeterminate. And why is this a reasonable answer? Because the 2 points that we are given is really only 1 point. 1, 2, 3, negative 2. It's just this point. Well, I can determine of the I cannot determine the slope of the line that goes through that point. Why is that? Because there's all kinds of lines that goes through that 1 point. I can't determine it until you give me a second point. If you give me a second point, if you give me this point, 7, 1, well then I can determine it. If 1 point is 3, negative 2, and the other point is 7, 1, I can determine the slope. If you go from negative 2 to 1, you went up 3. If you go from negative 2 to 1, negative 1, 0, 1, you went up 3. Or you can say hello to 0, right? Let me draw it again. You can say hello to 0. You went 2, and you went 1, you went up 3. And then if you go from 3 to 7, in the x's, you went up 4. So the slope is 3/4. But I can't determine it. It's indeterminate if you give me only 1 point. I don't care if you write the point down 2 times or 22 times. You only gave me 1 point. Okay, now, what if I give you the graph of a line and I say, compute the slope? Or I'll give you 2 points on a line, and I'll ask you to compute the slope. Here is your x-axis and your y-axis. And here's your grid. I'll draw it as well as I can. Okay, so what's in red? Those are your axes. Right, they're labeled anyway, so I don't really need to make that statement. Okay, So if you had some graph paper, it would look something like this. Hopefully a little better. If I ask you to find the slope of the line that contains those 2 points. We'll do this, we'll write down the computation on the bottom left. What's the slope between point A and point B? How you go between the 2 points is up to you. You can go from A to B, you can go from B to A, and while you're going from A to B, you can take any route you want, and if you're going to go from B to A, take any route you want. The only rule is you can only go up and down and left and right. You cannot go diagonally. So one way of doing this is to say start at A. You go up 1, 2, 3, 4. You went up 4. And that's a positive because you went up. And then you go to the right, which is also positive. You go to the right 1, 2, 3, 4, 5, 6. And you get 4 over 6, which is 2/3. You could have done that. Or, if you preferred, you could have gone from A to B a different way. You could have gone to the right immediately. 1, 2, 3, 4, 5, 6. So, you get 6 in the bottom. And then you go up 1, 2, 3, 4. And there's your 4, plus 4. And that still reduces to 2/3. That's one way you could have gone. But there's many, many others. Okay, so those are the 2 natural ways of going from A to B. But you could have gone from B to A. Nobody said you had to go from A to B. You could have gone from B to A. And if you went from B to A, one way of going would have been, so let's compute the slope over here. One way is you could have gone down 1, 2, 3, 4. That's a change in y. Since you went down, it's negative, and then go to the left. 1, 2, 3, 4, 5, 6. And since it's to the left, it's negative. And a negative over negative is positive, which I don't have to write down. And 4 over 6 is 2/3. Exactly what we got going from A to B. Okay, another way of going from B to A is you could have gone to the left first. You could have gone to the left. 1, 2, 3, 4, 5, 6, and then go down. 1, 2, 3, 4. So you go down 4 and you went to the left 6. It's still 2/3. Okay. Those are the 4 same ways of going. But you know what? You don't have to be same. You don't have to go that way. It's boring doing everything like everyone else, isn't it? I said from the very beginning, the only rule is you can go up and down, left and right. That's exactly what I said, and believe me when I tell you that's just what I meant. You can only go left and right and up and down. How you do that? That's up to you. Just go left, right, up and down. You could have gone from A to B. Well, first letters labeled A and B. I hope B was right there. Yeah, B was right there. Okay. To go from A to B, you could have first default 1. So long as you go left and right, up and down, you could have gone that way. Believe it or not, the slope is going to be the same. Let's do bookkeeping on the change in x's and the change in y's. Let's do the change in x first. So I started A. First I went 2 to the left, that's -2. Then I went up, so I won't count that. But then I went to the right, 1, 2, I went to the right 3, that's +3. Then I went up some, but then I went to the left 3. Then I went to the left 3, take away 3. Then I went up, but then I went to the right just 1, add 1. Then I went down some, then I went to the right 1, 2, 3, 4. I went to the right 4. And then I went down a lot, and then I went to the right 1, 2, 3, 4. I went to the right 4. Either lack of space, I'll put it here. Then I went up some, then I went to the left 2 spaces, take away 2. And then I went down 1, 2. Then I went down 2. Oh, I don't count the going down, excuse me. Let's get rid of that red. Okay, or the black. I went down 2. Okay, but then I went to the right 1. So I didn't mean to write that I went down 2, excuse me. So I went to the right 1, so that's plus. Well, this canceled out. -2 plus 1 is -1. Plus 4 is 3. 3 plus 4 is 7, plus 1 is 8. I went to the right 8 ultimately. So make sure I wrote this down, right? 3, -3, 1, 1, 2, 3, plus 4, 1, plus 4 again. Okay, somehow I didn't include that -2. I'm sorry. If I take away 2, then the 8 should have been a 6. Take away 2. Take away 2 and add 1, and we would have 6. Sorry about that. Now, for the change in y, I'm going to put that up on top here. Let's do good bookkeeping on the change in y. Okay, so I started at A. I went to the left, then I go up. 1, 2, 3. That's plus 3. Then I went to the right, and I went up 1, 2. Went up 2. Then I went to the left, which brought me right here, and then I went up 2 more. Then I went to the right, and then I went down 1, -1. Then I went to the right a lot, then I went down 1, 2, 3, 4. Went down 4, then I went to the right, then I went up 1, 2, 3, 4. Went up 4, I went to the left, and then I went down 2, and then I went to the right, and I'm at B. Okay, and plus 4 and -4 cancels. 3 plus 2 is 5, plus 2 is 7, -1 is 6, -2 is 4. So, my slope is the change in y, which is 4, change in y, which is 4, over the change in x, which is 6. What do you know? I get good old 2/3, just like I got the other 4 times I checked it. How you go is literally up to you. Just don't go diagonally. Just don't go diagonally. Left, right, up, down. How you go is up to you. As long as you just go left, right, and up and down. Like you're driving a car. You can only drive on the streets, which are parallel and perpendicular. You can't drive on the sidewalk. Now, what I want you to do is notice this. I mentioned it, but now let's see it in real life. I want us to compute a few different slopes and see that they're actually equal. Suppose this is point A, this is point B, and this is point C. Okay, I clearly didn't have to draw as much as I did. So let's just remove this one out. What is, let me erase it as well on my physical board. Now the question is, what is the slope? So we have this line. And like I said, the slope of the line is constant. It has one number. One portion of the line is not steeper than any other portion of the line. So the slope should be equal. What's the slope from A to B? Well, we'll go from A to B. You can go up 2 and 3 to the right. Well, up 2 is a change in y, and 3 to the right is a change in x. The slope is 2/3. Well, what about the slope from B to C? Well, from B to C, you can go up 2 and, oops. Okay, how are we going to fix this? Suppose there was, close your eyes for a moment, and here is your, okay. So how do you go from B to C? You go up 2 and you go 1, 2, 3 to the right. Up 2 and 3 to the right is plus. So it's 2/3. Well, what's the slope from A all the way to B? Well, we'll go from A to B, shouldn't be a problem. You go up 1, 2, 3, 4. Up 4, that's the change in y, and then you go to the right. 1, 2, 3, 4, 5, 6. Well, but that's still 2/3. All of them are equal. If you had perfect graph paper, you wouldn't have had to draw another line. The slopes are, and I do have a typo, it's not MAB, but it's the slope between between A and C. It's the slope between A and C. They're all the same slope, 2/3. Okay. Now, what if you are given a line, you are not given any points, given an ordinary line on your graph paper, and you're being asked to find the slope. Okay, so all you have is your grid. Doesn't even matter which is the x and y axis. Think about why it doesn't matter. Let me draw your grid. I'll put down some points, and we will calculate the slope. No, excuse me. I'll put down a line, and we'll calculate the slope. Okay, and here is my line. This is my line. Now, which points you pick, in theory, don't matter, as long as they're not the same points. Which points you pick, in theory, will not matter. But what you want to do is, you want to pick a point on the corners. Let me be crystal clear what a corner point is. These are corner points. This point is not a corner point. This point right here is not a corner point. You pick corner points, like this point right here and this one right here. Those hit right on the corners. That way we can count nicely. I go up a full one box, another full one, and another one, and another one. So I went up 4. The change in y was plus 4. Then I go one full box to the right, a second one, a third, a fourth, a fifth, 6, 7, 8, 9, 10. So it's 4 over 10, which is 2/5. That is the slope of that line. Now, if I would have picked this point and say this point, yes, the slope between them is also 2/5. I'm not going to go away from that. But what I will say is I can't compute that. Because I don't know how high I just went. Yes, I know I just went up one more. But then I only go up a little bit. How far up did I go? I don't know. Then I went to the right some. I don't know how far I just went. But yes, now I know I went one box, and another one box, and another one box. But then, I don't know how far I just went now. I can't count them. I don't know what it is. I don't know what it is. Maybe I multiply each by a third, and you can say I went up 2/3 and I went to the right 5 times the third, which is 5/3. Maybe I went up 2/3 and I went to the right 5/3. But I don't know for sure if that's right. And I don't know what to multiply by a third from, because I'm assuming that I never calculated the slope between those 2 points. I'm saying from the very beginning of this problem, if I would have picked these 2 points, I couldn't compute it because I don't know how high up I went and how far to the right I went. So you have to go from the corners. You have to go from corners. If you don't go from corners, you're not going to get the slope. You're not. Okay. On that note, that finishes the section on slopes. Good luck with it.